So let us come to this point. Overall, what is the use to know the errors? See, if in a measurement error lies, then we won't be able to get a true or accurate value of that measurement. That's why we must know how to get a true value of a measurement. Clear? So the simple way is, if the number of observations of that measurement will be more, then we may get the true value. So if the number of observations will be more, we will be approaching towards the true value. Clear? So now let us know this term. What is true value, absolute error, relative error and percentage error. From this portion, questions will come in your exam. True value, or that is otherwise called the most accurate value. Let us take one example. Suppose someone will ask you to find out the what the mass of this marker. Clear? If you take and measure, suppose you have one instrument and you can measure, in the first attempt the value whatever you get, that may not be the true value of the measurement. If you take 5 different observations, then if you take 5 different observations and find out the mean of it, that mean value or the average value will give you the closer value to the accurate value of the measurement. Suppose one physical quantity is there and you are measuring, let's say A. That physical quantity is A and you are measuring the value of that measurement. That may be any physical quantity. And you took, let's say, n number of observations. In the first observations, you get the value to be A1. In the second observations, you are getting the value to be A2. In the third observations, you are getting A3. And you took n number of observations of the same physical quantity. Got? So the true value or the most accurate value will be given by, that is A mean. You can say it to be A mean, or it can be written as to be A bar, which is equal to the mean value of this. Mean you can calculate in this way, means sum of all the values, A1 plus A2 plus up to AN divided by the number of observations, means n. So this value is termed to be your true value. Got it? So this is the process how can you get true value. See, if the number of observations will be more, if the number of observations will be more, means n, then this value will be what? You will get a most accurate value and the error will be less. Now comes to the error part. If we assume that this value is to be your true value, then each and every value you can find this difference. A bar minus A1. A bar minus A2. A bar minus A3 and so on. Got it? Suppose if you take 1 to 9, 1 to 9, got? You can find the average value to be your 5. Suppose you take the value 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8 and 9. So the average value you are going to get 5. That 5 can be called your true value of the measurement. And if you take, see, 5, your true value is 5 and the first observed value is 1. 5 minus 1 is 4. But if you take 5, your true value minus the last observed value, it is 9, you are going to get it is minus 4. In both the cases, you are getting the difference either 4 or minus 4. If you take the magnitude of it, you are going to get in both the cases the value will be 4. See, there are two varieties of errors. One is a positive error and the other one will be your negative error. Clear? But if you take the mod of it, means magnitude of the error, in both the cases it is 4. Clear? And the mod of the difference between the true value and the measured value, the mod, if you take the mod of this quantity, you are going to get your absolute error. So if you take mod of it, you are going to get it to be your 4. 4 is the absolute error. So if you take the difference, then mod of it, and you can say this is second term a bar minus a2, that to be your delta a2. Similarly, a bar minus a3 to be delta a3. So all these are the absolute errors in the first measurement. See, delta a1 is absolute error in the first measurement, delta a2 is the absolute error in the second measurement, delta a3 mod will be your absolute error in the third measurement. Similarly, we can get a bar minus an to be your absolute error in the nth measurement. So all these are called your absolute errors. Then we can get a term mean absolute error. Mean absolute error. Mean absolute error is termed to be your delta a bar, or sometimes it is written simply as delta a. Delta a bar is given, you can find it by like delta a1 mod plus delta a2 plus up to delta an divided by n. Means sum of all the absolute errors divided by the number of observations will give you the mean absolute error. Is it clear? Sum of all the mean absolute errors or all the absolute errors divided by the number of observations will give you the mean absolute error. Means just now we have discussed two things. One is your true value of the most accurate value or the mean value, and only the difference, that difference, they are called your what? Your errors. And the mod, if you take the mod of all the errors, they are called your absolute errors. And if you find the mean of all the absolute errors, they are called mean absolute errors. Now comes your relative error. Your relative error is nothing. So we can say RE stands for relative error, is nothing but the ratio between mean absolute error to the true value. So this quantity, whatever you are getting, you call it to be your relative error. Got? And if you multiply 100, if you convert it to percentage, then that is called your percentage error. Percentage error is what? Percentage error will be your delta a bar by a bar into 100 percentage. So this is your percentage error. And remember, every measured value is likely to reside, most of the times it's likely to reside between this value delta a bar minus delta a bar to a bar plus delta a bar. Likely, not like that all the time, but most of the time your measured value will lie within this range. Got? So students, basing on the concept of all the types of errors, let us find out or let us solve a question. Suppose you are measuring a time interval between two observations or two events. You are measuring the time interval between two events, and you have taken 5 different observations, and the time here I took the symbol T for the time, and all the 5 observations are like this: 2.61, 2.62, 2.60, 2.67 and 2.64. Now here you are asked to report the result and find out all these your true value, absolute errors, and absolute error, relative error and percentage error. So in this case, this is the procedure you need to follow. First you need to find out the most accurate value, true value or the mean value. There is a formula, means T1 plus T2, T3 plus T4 plus T5 divided by 5, as there are 5 observations. So if you add all these numbers, you are going to get 13.14 divided by 5, and you are going to get 2.628. Clear? So see here, our your measured value are up to 2 decimal places, but your calculated value is coming up to 3 decimal places. So in this case, what you need to do, you need to round up. Rounding up rule is there. See, you see the last digit. If the last digit is greater than 5, if the last digit is greater than 5, then add 1 to the previous digit. So what I did here, that is 2.628, 8 is greater than 5, so I have added 1 to the previous number, which is 2, so it is coming 3. If this number would have been less than 5, then you would have simply dropped. Suppose example, if this would have been 2.624, simply you could have written 2.62, as the last digit 4 is less than that of your 5. But so you see your true value is coming to be 2.63 after rounding up. Now you need to find out the absolute error in all the measurements. The formula is what? Your formula is the difference between the true value and the measured value. That is your errors. And for absolute error, you took the mod of it. What I have done, in the first measurement, I found a delta T1, which is 2.63 minus 2.61, because first measurement 2.61 and 2.63 is your true value, and it is coming out to be 0.02. Similarly, I found all the absolute errors in all the measurements. So we have 5 measurements, so I got 5 absolute errors. That is 0.02, 0.01, 0.03, 0.04, 0.01. Now comes to your mean absolute error. Mean absolute error, our formula is what? It is the mean of all the absolute errors. So we got 5 absolute errors here. So I have added, since 5 observations, I divided it by 5. So I am going to get this is added here, and I am going to get 0.11 by 5. So the result is coming out to be 0.022. See, since again we need to round it up. Why? Because the value is coming 0.022 and we need to round up. You just see here, the last digit is 2. Last digit is 2, and this 2 is less than that of your 5. Simply you need to drop. Why we will round up? Because our these absolute errors, they are up to 2 decimal places, and which is coming out to be here 0.02. Now your absolute error is delta T bar by T bar, which is 0.02 by 2.63, which is coming out to be 0.0076. And the percentage error, you have to multiply 100 with it, and you are going to get 0.76%. Now we can report the result, that while writing the result, you can write our measurement would be given by, that is 2.63 plus or minus, that your error you need to add 0.0076, that you need to write here. This is the way you can report your measured result. Thank you.